Welcome to Algebra 1 with Miss Betsy, and we're going to be continuing our discussion of polynomials today. We're going to see that this is a super easy assignment section. You go from really hard to really easy. This is an easy one for you. We're simply going to be adding together polynomials. For my text for this video with my torn page, if you watched the last video, you saw me throw the book on the floor and tear it. Algebra 1 for Christian Schools, second edition, published by Bob Jones University Press. We are using the third edition in some classes. Some of you are using third edition. The numbering does not coincide, but the material that's being contained in these lectures does so. So just make sure that you're studying about adding polynomials, and if you're in a Christian school and you're a public school and you simply want to learn about adding polynomials, watch this video. It'll show you what to do. So let's go ahead and pray, and then we'll get started on this short video. God, you're awesome, and I am humbled that you love us, that you listen to us, and that you know my voice. Father, I ask that you would help me to communicate clearly today. I ask that you would give the people on the other side of this computer screen the ability to understand and to comprehend the topics that we discuss. And I thank you for that in Jesus' name, amen. Okay, my co-op kids, I know you're just crushed that I forgot the lame joke in the last one. So here we have two special today, two. How do you keep a dog from barking in the back seat of the car? Well, that's a really easy one, guys. You just put the dog in the front seat of the car, and then he's not barking in the back. And now, what do you get when you cross a bear with a forest? You get fir trees. So, adding polynomials. We learned last lecture that polynomials are collections of terms that are divided by addition or subtraction symbols, and that they have special types of polynomials, but all polynomial means is that it has many terms in it. We have two polynomials here, 1, 2, 3, 4, that have 4 terms in it. 1, 2, 3, 4 terms in it, so we don't have a special name. This is just the first polynomial. And then because we have 4 terms over here, this is no special name for that either, and it's a 4-term polynomial. They are both first degree polynomials because the highest degree of any term in here is first degree, or degree 1. And if that doesn't make any sense to you, go back and watch the video for classifying and evaluating polynomials. If we want to add 2 polynomials together, we can do this 2 ways. The first way we're going to do this is that we're going to align the problem vertically. So if we want to add these terms together, we're going to align them vertically so that like terms add up. We have 3a plus 2b minus 8c plus 8, and then we're going to add to this 2a minus 4b plus 6c plus 9. Now this is just my own little thing that I do. I write a memory jogger out here to help me remember that I'm going to be adding these 2 polynomials together. And I do that because sometimes you can subtract. Sometimes later down the road you're going to know how to multiply. And since I clearly don't dye my hair, I don't always, it's easy to forget what you're doing with the addition and the subtraction signs in there. So write yourself a little memory jogger here. We're going to add together these 2 polynomials. And usually when you add from right to left. I'm going to see if they even address that at all. We're going to add the like terms. We have A's, B's, C's, and constant terms. Because I'm very accustomed to adding polynomials, I like to add from left to right, because unlike with addition where we have carrying, there's no carrying involved when you're adding like terms together, adding polynomials together. And it helps you to get your spacing correctly. How do you add like terms? You add the coefficients. 3a plus 2a is 5a. 2b plus a negative 4b minus 2b. Negative 8 plus 6 gives us a negative 2c. 8 plus 9 is 17. 2 plus 3 is 5. 2 plus a negative 4 is negative 2. Negative 8 plus a positive 6 is negative 2. And 8 plus 9 is 17. So the sum of these two polynomials, and you can verify this in your book, is 5a minus 2b minus 2c plus 17. See, it is just hard to get much easier than this at this point in Algebra 1. It's just they're teaching you vocabulary and they're setting the very basic structure for dealing with polynomials. So let's do another one. I think surely it's got to be a little bit harder than this. So let's go ahead and do our second example. And this one is going to look a little bit different. We have three different polynomials that we're going to add. We're going to add 2x squared plus 3xy plus 5y squared. And they have it in parentheses just to help you differentiate between these polynomials. We have 8x squared minus 5xy plus 3y, and then we have a third polynomial, x squared plus 2y squared. And they want us to add together these three polynomials, and first thing you need to do, make sure you copied your problem correctly. So I have 2x squared plus 3xy plus 5y squared, 8x squared minus 5xy plus 3y, x squared plus 2y squared. So I've copied everything correctly. Now before we add these, let's review how we classify this. We have three terms in here. This is specifically called a trinomial. The degree of this term is 2. The degree of this term is 2. The degree of this term is 2. There's no highest degree term. So this is a trinomial. It's second degree. So this is a second degree trinomial. We have another trinomial because we have three terms in there. Let's see what the highest degree term is here. Second degree, first degree. So this is a second degree trinomial again. Down here, x squared plus 2y squared, we only have two terms. This is a binomial, and again, it's a second degree binomial. Now what I said with our last example is that we want to go ahead and line these up vertically. So we have 2x squared plus 3xy. Let's see if you're going to have me do that now. And I'm going to deviate from what they say here in the book, but you'll see in a moment. 2x squared plus 3xy plus 5y squared. Now we're going to add our next. We have 8x squared. Actually, I won't change it on this problem, but I'll explain to you how I would change it. Plus 3y. Oops. If we're going to add vertically, can we add these two together? Does this become 8y squared? Or is it 8y? Or is it 8y cubed? How are we going to deal with this problem here? Remember, we can only add or subtract like terms. And how you define if two terms are like terms? The variables, the terms have to agree in variable, and they do. They're both y's. But they also have to agree in exponents. We've got a second, a 2 for the exponent here, and a 1 for the exponents. So you cannot add together these two terms. And I very deliberately wrote it as I did, because that's what you're going to do a lot of the time when you're first learning how to add together polynomials, is you're going to misalign them. We don't have a y squared term, so just like you put zeros in for placeholders in arithmetic, we're going to have to leave a space here. Plus 3y. Now they don't show you this. I'm going to write it. If it helps you, put in the missing term. Say plus 0 y squared. We don't have any y squareds, but that will help us to keep up with where we're at. Our last term now, we have plus x squared, and we have plus 2 y squared. We're going to add all of these vertically. I've got some empty spaces there, and we can go ahead and do what I said to do. We can say, if you wish, that we have no xy. Also that we have no y. Also that up here we have 0y. What I have in brown on the board, totally voluntary at this point. If you're having a hard time wrapping your mind around how to add together these terms, put those placeholders in. Now we have x squared, xy, y squared, and y. So we have like terms organized vertically. We add the coefficients. 2 plus 8 is 10 plus 1. Don't forget that that's 1x squared. So this is not 10x squared. It is 11x squared. Plus 3 minus 5. We have a minus 2xy. Plus 5 plus 2 plus 7 y squared plus 3y. Let's check your book and see if I got this right. We have 11x minus 2 plus 7 plus 3y. And I want you to notice that the x's are going down. X squared, x, y, y squared. If I were doing this, I would have reversed the order in which the y and the y squared term comes, but it doesn't matter. Sometimes you cannot get the ascending, descending order of the powers of the variables to work. So that's what's involved here. The key to this example is to recognize and to remember that you can only add like terms, and that like terms have to agree not only in variable, but they have to agree in power, or with the exponent has to be the same as well. So they're going to be wholes that you're going to have when you're adding together polynomials. All right, let's look at our next example. Now, you can also add polynomials horizontally. It makes for a long stretch across your page, but it can be done. So let's go ahead and look at example 3. This says add 3x squared plus 2x minus 5. This says add 3x squared plus 2x minus 5 and 8x squared minus 7x minus 10. 3x squared plus 2x minus 5, 8x squared minus 7x minus 10. And we want to add together these three polynomials. And what they've written here are very specific polynomials that you're going to deal with constantly. They're second degree trinomials. So they're just sort of giving you a little foretaste of what you have to come. They're trinomials because they have three terms, 1, 2, 3. 1, 2, 3. 3 terms in each, so they're trinomials. They're second degree because the highest degree term in this trinomial is your first term, which is x squared. So these are both second degree trinomials, and we want to add these together. So this one, there's nothing to it. You say 3x squared plus 2x minus 5 plus wow, that smears, plus 8x squared minus 7x minus 10. Now we're going to look for like terms, and even here I'm going to slash out as I add them. I have 3x squared plus 8x squared is 11x squared. Positive 2x minus 7x is a negative 5x. Negative 5 minus 10 is a negative 15. And we get, when we add together these two trinomials, we get a trinomial for our answer. It is 11x squared minus 5x minus 15. And you noticed as I'm working here, I'm very, very comfortable adding together negative numbers and positive and negative numbers in my head, which is what you need to be doing. And you need to have a real comfort level adding and subtracting integers, which is what positive and negative numbers are. This was straightforward because it was. Let's see if they're going to give us one that is a little more challenging, and they may not until we subtract. Okay. We'll just do one more. This is example number 4. And we're going to add together 15a squared minus 7ab plus 3c squared minus 12b. Has 4 terms. There's not a special name for it, it's just a polynomial. So we're going to add 15a squared minus 7ab plus 3c squared minus 12b, and we're going to add to that a trinomial, and I'm just going to go ahead and say plus. So we're going to add this trinomial here, 8ab plus 12c squared minus 3b. So we're simply going to look for like terms. When you order together a polynomial, you're going to want to start with the highest degree of a variable, put that in descending order. Theoretically and hopefully other variables will follow naturally behind in ascending order. So we're going to start with 15a squared. I have 15a squared, I have no other a squared terms. 15a squared, I'm going to move down to 15ab. So I have an ab here, and I have an ab here. Negative 7 plus 8 is a positive 1. But you don't use 1 as your coefficient. Remember that we have what looks like no coefficient there, and we understand that that coefficient is 1. Now, do I have any b squares? I don't see any b squares, so let's just go to b. Negative 12b minus 3b gives us a negative 15b. What do we have left now? Positive 3c squared plus 12c squared gives us plus 15c squared. That's all that is involved in adding together these polynomials. Now, look in your book. It says 15a squared plus ab plus 15c squared minus 15b. Order doesn't matter here. Remember, with addition and subtraction, order is not going to matter. 5 plus 7 because it's commutative. 5 plus 7 is the same as 7 plus 5. If you had chosen to, see what they did was they said first we had 15a squared minus 7ab plus 3c squared. So they went with the c squared term. Makes no difference whatsoever. Okay, that is the end of our video for 8.2. I'll see you next time.